Hi everyone, in this video we will solve three limits and you have to use Hopital rule to find these limits. And as you know that Hopital rule says that if the direct substitution for x equals to a and the limit is 0 over 0 or plus minus infinity over plus minus infinity, then limit f over g equals to limit f prime over g prime. So we will start with part A. In part A, you have to make direct substitution up and down when x goes to infinity. So the direct substitution is infinity square, which is infinity over e to the power infinity. And e to the power infinity equals to infinity, so we have infinity over infinity. So we can use Hopital rule. So you have to find limit f prime over g prime. So our limit is equals to limit derivative up 2x over derivative down, which is e to the power x. When x goes to positive infinity, now plug in the positive infinity up and down, you will get 2 times infinity, which is equals to infinity over e to the power infinity, which is equals to infinity also. So you have to use Hopital rule second time. So you have to find the derivative up and derivative down. So we have limit derivative up is 2 over derivative down is e to the power x when x goes to positive infinity. And this is equals to 2 over e to the power infinity, which is equals to infinity, and number divided by infinity equal to 0. So in part A, we used Hopital rule twice. So maybe you have to use Hopital rule more than once, 2 times, 3 times. It depends on the question. For the second question, we have limit e to the power 2x minus 1 divided by tan of x when x goes to 0. So you have to make direct substitution to find if we can use Hopital rule directly. So e to the power 0 equals to 1 minus 1, 0 over tan of 0, which is 0. So since the direct substitution is 0 over 0, so we can use Hopital rule directly, and you have to find the limit of derivative up over derivative down. So the limit equals to derivative up, we have e to the power 2x, you have to derive the power, which is 2 multiplied by the same exponential function, and derivative of negative 1 is equal to 0. Since negative 1 is a constant, the derivative down, derivative of tan x is secant squared x when x goes to 0. Now replace x equals 0, you will get 2 multiplied by e to the power 0 divided by secant squared 0 equals to e power 0 equals 1 multiplied by 2 equals 2 divided by secant of 0 equals to 1. So we have 1 squared, which is equals to 1. So the answer is equals to 2. Part C, we have limit of len sine x over len tan x when x goes to 0 from right. So you have to make direct substitution to know if we can use a Hopital rule directly or not. So direct substitution is equals to len sine of 0 equal to 0 and tan of 0 from right equals to 0 from right, and this is equals to len of 0 from right equals to positive infinity divided by positive infinity. And this is the case you can use Hopital rule directly. So you have to find limit f prime over g prime. Limit of derivative up, you have to find the derivative of the inside functions, side function, which is cosine x, over the inside function, which is sine x. This is the derivative of the numerator, and the derivative of denominator, you have to find the derivative of the inside function, and derivative of tan is equal to secant square x divided by the inside function, which is tan x, when x goes 0 from right. And as you know, cosine x over sine x equals to tan x, and you have to convert divide to multiply, and multiply by the reciprocal of this denominator. So cosine x over sine x equals to cotan x multiplied by the reciprocal, which is tan x over secant squared x. So this is equals to limit, and as you know, cotan x equals 1 over tan x multiplied by tan x over secant squared x when x goes to 0 from right. Now you can cancel tan x with tan x, and you will get limit 1 over secant squared x when x goes 0 from right. And as you know, secant of 0 equals to 1, and 1 square equals to 1. So when we plug in the value of x, which is 0, you will get 1 over 1, and this is equals to 1. And that's it. Thank you.